Hey, engine professionals, machinists, and enthusiasts. Welcome to the Engine Professional Podcast.
Well, Chuck, here we go again. Another podcast. Summer's flying by pretty quick. And you know what? I got to apologize. It's been pretty hot up here where I am. And I know we're sending some smoke down your way. So it's just like winter. We get blamed for the Arctic front when we blow down some cold weather. So you know what? You can have a little of our smoke, I guess, this year because trees are burning. So that means you get to see some of it.
Yeah, that's a fact. I'm up in Cary, Illinois today. AERA headquarters are actually all week. And I've noticed that it's pretty hazy up here. And today we have gorgeous temperatures and so forth. So we know it's not the oppressive, stagnant humidity that you would see in August or September, as it lays in on us. But yeah, the smoke's pushed down. So yeah, thanks for that.
Well, you're welcome. But the good news is, I mean, the way summer's flying by here, we're going to be into our cooler temperatures and we'll be, everything will be clear again. So that'll be something to look forward to, I guess. And I guess speaking of toasty, you know what? This kind of goes hand in hand with our topic this week. For this podcast, we're talking about piston and piston failures. So you've got some really good slides coming up that we're doing a little bit here, and you're going to show us some piston failures and through our failure analysis manual. And so we're going to see all kinds of toasty pistons, that you got to show us. And speaking of pistons, our associate members here at AERA, they play a very large role for us. They're big supporters. As most of you know, we have our member shops, which is our active members, but we also have associate members, and these are companies like manufacturers, and they're a huge support for us. So if you haven't heard of UEM or United Engine Machine, believe it or not, they've been around just as long as we have. They've been around since 1922. They're a fourth generation company. They make products like Silverlight pistons, Icon Forge pistons. They have their Dualloy line, their Keith Black Hypertectic line. They've got their KB motorcycle line, as well as they're the ones that are licensed to apply the speed of air technology to their full line of medium duty pistons. So again, if you want to check them out, they're at uempistons.com. And again, we want to thank them for everything that they do for us. They're great supporters.
Yeah, true, Rob. I think actually it's been shared at some of our tech and skills regionals, kind of jumping back to those. I think they have the patent on the Nyresist or the Alphenbahn ring insert for the diesel piston. So anyway, we'll talk more about that in maybe an upcoming podcast or something. But that is something that's unique and interesting to UEM.
No, for sure. And we've been busy the last little while. Since our last podcast, we've had a couple regionals. We did the Edmonton, Alberta, Canada regional. We were up there. That was a really good turnout. And it was nice to get up to Canada to help share and get some information out to those folks. I know you were at Goodson. That was back in June. And I know you got to go to the car museum there. I heard really good things about that one.
Yeah, what a terrific facility. Rinlinger, I'm probably butchering the name, but they have a auto auction house and kind of like a Meekum thing. So it's typically unique high dollar vehicles that they run through. And the museum that they put together is fabulous. So the area where they actually run the cars through, they've made it look like an old town. There's storefronts and stuff. It's very cool. If anybody's ever been to the Henry Ford, you got Greenfield Village. It plays on that a little bit. So it's like you can walk through history. You see signs and cars and, kiddie rides and all kinds of stuff. Just really harkens back to, kind of anywhere from 1920 to uh, maybe 1980
Wow.
at last. But anyway, just terrific place, good presentations. As a matter of fact, the UEM actually did a presentation there.
No, that's cool. And you know what? I know we had our production meeting earlier this week, and I know we've AERA's got all of their regionals lined up for 2026 already. So for everybody listening, watch out for some dates there. We're going to nail those down, but we've got a great lineup as well for next year. So looking forward to that. And then just recently, I was out at the ASC Instructors Conference out in St. Louis. That, for those of you that don't know what that is, so there's approximately 400 high school and college instructors. This is a great place for them to get their professional development hours that they need to continue on with their certification and accreditation. They can get all 20 hours they need right at this particular conference. So it's loaded with all kinds of training, presentations, and events. I really love talking to the instructors. I mean, they are the future of our industry. Nice to hear what they have to say and talk about some of the bright minds that they've got coming through their shops. And always look forward to that one. So that was back in July. We always look forward to helping those guys out again moving forward for sure. And then Chuck, looks like you're going to be out at the PERA convention. So that's coming up September 17th to 19th out in Minneapolis. So I think you got some stuff going on for that one too.
Yeah, absolutely. And it's always good to get, very similar, a lot of work with the manufacturers. So our associate members, as we had to speak to them. And a lot of the people may not understand, but most every production engine rebuilder is also an AERA member. So, we provide technical data and things of that nature. They have uh, a different program, they're mass uh, production shops, and it is a different model, but a lot of the same players. So anyway, we contribute. We've been asked to do presentations in the past and so forth. So it's a great working relationship, and we're happy to be a part of it.
And you know what? I kind of call it, it's a little bit like train the trainer. Just it's important for us. We're always learning every single day. So I encourage everybody, even like Chuck, you're going to be going out there and learning as well as, again, it's just, you're training the trainer and this stuff, any kind of professional development like this really does play a part in helping us learn what you're everybody out there in industry is our eyes and ears as to what's going on. And these are just one of those events that we all learn from.
Right, right. There's a kind of a self-help book, and it's called Eat That Frog, and one of the things that is spoke about in there quite a bit is as you learn more, it gives you the ability to learn more. So continuous education, always learning, right? Pick it up where you can, when you can.
Exactly. Yep. No, and this industry is changing so fast and engines are changing so fast. Yeah, it's always a learning curve for sure. So Chuck, you've got like I say, we some of the calls and that we get piston related. A lot of times they're, that they'll send us images, for example. We'll get to see, what it is that's going wrong, and a lot of times, folks have a hard time. Maybe it's a misunderstood a little bit as to what's going on with that piston. Like sometimes the machine shop is taking the blame because it's there's just the customer says there's not enough clearance or you didn't set your ring gaps right. But sometimes the piston can fool you, and there's actually a lot of other stuff going on, little hidden things that maybe you weren't aware of. So Chuck, I'm really looking forward to today. I'm glad you put this together, and I'm just going to pass it over to you, and you can just take the lead on this one.
Yeah. So thanks, Rob. And kind of where this came from is, our buddy Chris Hammond, Lakeland Auto Marine. We have him doing several, presentations for us. And he always talks about the case studies. So I'm going to kind of just use that verbiage just a little bit because this is an actual example of a piston related failure. Let's call it that. So, you know, the reason I have this first slide up here is the failure analysis manual. So I'm going to use that as some reference material to kind of support some of the discussion that we're going to have here. So I'm sure anybody that's a member, they're quite well aware that we have this failure analysis manual, and it's one of the things that we actually sell as well. So we'll talk about that further. But failure analysis is a key component to engine machine shop, engine building. It's very, very important. So, so kind of where it started was I got a picture texted to me and said, "Hey, what causes this?" And there's, a few things that can attribute to this pattern that you see in the cylinder. But um, when you take kind of a deeper dive and start to look at, okay, I see some that it was the top the compression ring because of where it stopped in the bore, right? And then if you can see my cursor, um, you can see not only did I see some of this happening with the top ring, I had it with the second ring, and I had it with the oil control pack. Looking around the top of the bore, this is a diesel, it was a Duramax, so there's nothing that's, looks too crazy there because they make a lot of carbon anyway, right? So we're pretty familiar with that. So what will cause situations like that, though, are stuck rings. Okay, stuck rings, but why? So in this particular case, I was again fortunate enough. I ended up getting the parts when the thing was pulled apart. And okay, what things contribute to stuck rings? Dirt in the groove, um, bore distortion, fuel wash, oil film breakdown. Those are some of the top tier kind of stuff. The bore distortion, what happens is, we know that rings rotate in the bore, or they're supposed to rotate in the ring groove slash cylinder bore. The crosshatch angle is actually what dictates how quickly they rotate in the bore. And it also has an impact on oil retention in the cylinder. So if your crosshatch angle is really steep, it allows the oil to drain back to the crankcase more quickly. If it's real shallow, it holds more oil in the bore in the valleys. So, there's a lot of talk about RPK, RK, RVK. So crosshatch combined with the valley or the roughness depths impacts how much oil you keep at that interface. So if you have excessive bore distortion, you just create an easy path for the stuff to leak by. And then what happens? The parting line of the ring usually gets turned to that spot, then it quits rotating. So once it's got that distortion area, blow by gases go to the crankcase. Then when you tear it an engine down and you see your top and your second ring are both aligned, most of the time that's because there's a situation of blow by. Now, the top ring's going to rotate at a different speed than the second ring. We stagger our rings at 120-degree separation with build engines, but they move around. They're constantly moving. So you might tear an engine down and catch that they are aligned, and it may not be bore distortion, but usually if they are aligned, it's a good indicator that you have bore distortion.
So,
Um,
so Chuck, sometimes you see pictures, a lot of times, especially on people that maybe aren't familiar, you just put an engine together, for example, and you've rolled it over and you see similar kind of scratches. I mean, not nearly as wide as the ones that you've got in your picture there, but you see these scratches in the bore that are going up and down. And, you know, can you share with us, is that a problem or is that something that we need to be concerned about?
So there's depending on the lapping process of the rings. So if the rings are not totally lapped in, or the cylinders are fuzzy, so if you don't have a finish brushing kind of process to get rid of torn and folded material to really really clean those bores, you can have some laying over of the fuzz. So again, it can be the lapping process of the rings, but that should not be really impact making a huge impact on your surface finish specs. Like if you measure them, ideally you don't want to see those at all, because modern engine stuff, we put stuff together that is mostly broken in, right? That's what most of your manufacturers advertise as why they lap the ring faces, and why they do the diamond lapping of ring faces, why you should put so much effort into your cylinder bores, because we don't have time as we did, 80 years ago for these break-ins. Nobody's patient enough for that anymore. So we have to be very good at making the stuff ready to go when it goes out the door. So that's not ideal, but that's probably what some of that is. Um, and if the it does leave a potential for more of exactly what we're seeing here. If that fuzz is breaking down, becomes a situation where it starts to micro weld, right? Then it can get much worse. So again, here we can see this is definitely dirt related because I have enough parts and pieces to look that I have embedded debris. So I have some copper colored kind of parts in here. And as I had more conversation uh, with the shop that shared this stuff, like, yeah, this had a bottom end failure, but we were curious about, initially it started, the head comes off and you see the stripes in the bore. And then as you get further into it, well, yeah, we had a bottom end failure. Well, that had an impact. So as the crank's throwing oil around, it's got a brace of media in it. Now it gets embedded in the soft graphite on the skirt. Uh, we were able to actually magnify this and see very well that we have copper in the graphite coating on the skirt. Just more of the same, but it's a different area of the piston. So there's quite a bit of that material that's getting the ring stuck. I'm going to jump back one because this is up pretty close. But you can see these rings are chrome plated, so that's very tough material, and you can see the striations where the abrasive has worn through there, and even in the aluminum between the second and third groove. So uh, just attention to the details like that, and that can really help you in future diagnosis.
So Chuck, that piston, that would be replacement. That's the only, like, that piston is now deemed garbage. Would you agree, or is that usable?
Absolutely,
Yeah.
yeah,
Okay.
yeah. That's scrap aluminum.
Okay.
Sell it with your beer cans.
Right. Yep.
And so this is the stuff that we have, in the failure analysis manual. So wear caused by dirt or contamination. And so there's, a good little bit of detail in there. The patterns, root causes, we kind of tell you where it's coming from. And oftentimes, if you look at our failure analysis manual, we're going to have solutions. Well, when it's dirt, what's the solution? Avoid the dirt, make sure it's, we say cleanliness is next to godliness. So make sure that when you're doing what you do have in your control, so the block machining, the head machining, all that stuff, make sure that it's clean. And, on the customer end of it, aftermarket air cleaners are probably one of the, okay, how do they make it breathe better? Well, they have a bigger matrix for the air to come through. So if you don't maintain that with the oils and whatnot to capture the dirt as they start to dry out, well, you know, it's kind of like you know, a screen mesh. It's, it's square and it's open, and you're going to see uh, particles and abrasives and stuff go to the engine, and it's going to be bad for everything. Here's another area of embedded debris, and I thought, this is something that again will, as we talk about piston designs and changes over the years, a lot of people probably don't realize that a lot of modern engines actually have piston pin bores that are trumpet shaped, so they're purposely larger on the outboard area, and like piston pins, you get some deflection, and a lot of times they would score at the ends, and so they've modified how piston pin bores are made to accommodate some of this. So with CNC machine technology, you can do that. But now that we don't have that real close fit area here, it's a little bit looser out on the edges of this piston pin area, because this is the box area on the underside of the piston. But you can see there was some pretty good size abrasive that was between the piston and the pin and stayed there. So again, now I have more clues to the failure because I have all these parts and pieces to look at. Again, more on this is another page from the failure analysis manual. So we have the piston skirt abrasion damage, dirt built in from the engine machining operations, bead blast, sand blast, carbon particles. Again, got to get it clean. In this application that I have, so we looked at the piston and we looked at the contamination. So now we can move on. I also had the rings to take a look at. So as when these things stop rotating and I lose that the film between the interface of the ring and the the cylinder bore, I start to have micro welding. So I'm not moving lubrication. My oil film is broken down, and now it starts to weld. As it starts to weld, what does that do? It's kind of that rolling up of the dirt, in this place, and it's weld beads. So now it means more and more of the piston ring's not against the bore, right? Because I now have this stuff in between the cylinder and the ring. So now it just exacerbates all of my leakage. And when this starts to happen, now it's more carbon and stuff getting into the crankcase. So it's like a snowball. You know all about snowballs and avalanches in your part of the country. So once you get that snowball started, it can get pretty ugly.
Right.
So some of the contributing factors are, again, lack of lubrication from fuel wash. Could be your honing practices. We talked about the roughness of the cylinder bore, valley depth. So you need to really, consider that, analyze that. And that's changed because years ago, when everything was nearly moly top ring and not moly steel, it's not chassis. This is molybdenum. That's a It's a powdered metal spray that's applied to the face of the piston ring. But as we've moved in technologies and cylinder pressures are higher and detonation forces and stuff are much higher, we've kind of moved more away from moly and we're using steel rings with gas nitriding or PVD coatings or so forth. So now the surface of finish of the bore is that much more important. So moly was very forgiving when it come to lubrication. Now we have to be a lot more strict in following process of honing. So the no rotation that we were seeing, again, going back to dirt, bore distortion, and the ring to the groove fitment. So, you have to have enough clearance for some thermal movement, right? But you can't have so much movement that it's going to be a sealing issue or oil control issue. So now, piston rings, again, we're just kind of jumping out to our failure analysis manual and we take a look at, what the definition of scuffing is and some of the contributing factors that could potentially be leading to the scuffing. The upper cylinder debris. So where does that come from? So this is foreign material, potentially from water passages of the cylinder heads because we didn't have the heads clean enough. Uh, and I think people know how that is. It seems like it grows. It's like rabbits. They do dirt in water jackets flourishes. So you got to really do a good job getting the steel shot out from the cleaning or the blasting media if it's aluminum head. Uh, Old material from when the engine ran and the coolant stuff breaks down. I mean, you know what's in there: mud, grit, nasty junk. So if you don't get that all out, and then you're trying to set the cylinder heads on your freshly rebuilt short block, no matter how clean that short block was, well, you just contaminated it. If you have a defective induction systems, and now with all kinds of stuff being turbocharged, you have boost. So, whatever trash gets in there, it makes it much easier for it to get into the cylinder. Things like ejector failures, if they come apart, there's very, very hard particles that are going to go in the cylinder. So a lot of damage. Glow plugs, say if you have a glow plug, uh, it's not cycling as it should. Maybe it stays on too long and then it overheats and they swell and then they fracture and they end up in the bore. Mentioning spark plugs here. Yeah, this is actually a Duramax piston we're looking at, but in automotive applications, we recently did a bulletin about. Uh, it was one of the OEs. I forget exactly which one it was, but they had like a spark plug ceramic failure, and And I don't know if it was detonation or was the, you know, initiating that or what. But anyway, they were saying pull the spark plugs out, look for ceramic failure on it. If you see ceramic failure, the engine comes out because that ceramic's tougher than anything it's going to come in contact with. It's going to destroy the cylinder. So a lot to be learned from, just again, a journal. Uh, Now, this is something that was picked up kind of along the way. We weren't really necessarily looking for this, but it is something to keep an eye on. So piston rings are typically ground very, very smooth. They run through like Blanchard grinders and then they get lapped and polished. So they'll have a lap that's spinning, say, clockwise and one counterclockwise. And and that's how they grind the side faces of the rings to get the flatness, surface finish, and so forth. But you can see if you get too aggressive with anything like cutting valve seats, or you get chatter. So why is that a problem? What does this hurt? So the rings under pressure have gas that comes behind into the ring groove, gets behind the ring, and forces it out against the cylinder bore. So if the rings, as the piston's traveling up and it's sealing the ring against the bottom of the groove, if I have chatter, then I have leakage. That's not good, right? But how does a piston ring transfer the heat from the piston to the bore? By having good contact. So if the ring has a 20% loss in contact between the ring groove and of the piston and the piston ring itself, then it's going to reduce the amount of heat that can be transmitted to the water jackets to the cooling system, right? So, the details matter. You always say the devil's in the details. These little details matter. So if you see something like that, it means that the rings weren't ground adequately to ensure that they have good full contact. Again, this was a kind of a secondary thing, not necessarily the whole reason this thing failed, but it could have been a contributor, especially when, again, going back to that snowball, once things start to come off, the wheels come off the bus, it only gets worse. Um, and then along the way, looking at this, just some helpful tools. This is the image there. Well, I'll go back first. The failure analysis reference material. So having something that you can correlate to. Everything's about having a standard, right? When you set up your mic, you check it with a standard, calibrated standard. Uh, if you have a profilometer, you compare it to a calibrated standard. If you're going to look at, piston failures, bearing failures, you want to look at some kind of journal of failure. So our failure analysis manual is a good thing to refer to for that kind of stuff. Here I got a portable digital microscope. And when we were talking about this earlier, I'm like, I don't think I paid $50 for the thing. They're super cheap. And I looked today, so here we are, you know, 2025, and the thing's like $27. It's USB. It's got a little scroll thing on it. You can increase the light intensity or decrease it. It's got 8 LEDs in it. It's 1,000 power magnification. Uh, it'll take video or still shots. I keep mine in my backpack. It's great. I have a jeweler's loop to look at parts with. I have this little guy, so yeah, I'm a geek. I'm a nerd, but I pack this stuff around with me all the time. It's great. Um, an oil sample analysis can tell you so much because they know what's supposed to be in the oil. So there's a good baseline. Get the sample done, and what else is in there? You can, and I think we talked about this in a previous podcast, but every element you're going to be able to pick up when they use an infrared spectrometer to take a look at this, and then you can analyze each atomic element that is in the oil, and you can quickly say, okay, that's aluminum oxide. So that probably came from a polishing belt or crank grinding wheel or something of that nature. So it's easy to get that kind of data and help you steer you. Is this my dirt in the machine shop? You know, because there's certain dirt you're going to produce in the machine shop that maybe a garage isn't going to produce. So you can analyze the stuff different, you know, and help you get to root cause. And another thing is everything you tear down, you know, create a journal, uh, and then keep that for, you know, some repository history. So what, you know, take pictures, keep dates, questions, and what were the responses. And when you are working with someone, remember this: it doesn't matter. It's about this particular case, but always try to get a answer that doesn't allow, or get a question formed that doesn't allow the answer to always be yes or no, right? Because you know what people usually say, especially when they're frustrated. Okay, what was the cranking compression? That was terrible. Oh, hey, when you did a cranking compression test, what were the values per cylinder? You know, that helps me answer what's going on here. When you did a leak down test, what was your percentages per cylinder? Was the leak down good? Yeah, it was good, but it still runs like crap. Or no, it was terrible. What are you going to do to help me out? So try to get stuff where you get, you know, good, conclusive, data driven answers, and usually numbers help you a ton. So just keep that in mind. You know, don't let someone just yes no answer you, because that kind of gets you both nowhere. And so that again, here's how you can get the engine failure analysis manual. So it's a www.aera.org/store AERA failure analysis manual. And so currently today it's $49, and it's one of the most popular manuals that we have. And we actually had to go in to reprint before we were actually through our cycle, um, to get these out there, because it's been extremely popular, because we've had some of our other member shops that have also promoted this manual for us, and it's really picked up how much of this manual we actually sell, doing like over the counter sales. I'll call it that. But anyway,
And it's amazing, Chuck, how this manual can help sort of stop an argument of some sort. You know, like a lot of times shops are talking to their customer, and sometimes the customer just doesn't always believe the shop. You know, they think that the shop is out to get them. But when the shop can open up their failure analysis manual and say, look, the AERA has recognized that, you know, this particular component or your piston that you've got, this is exactly what has happened to your piston. Here's your piston. Here's the picture in the manual. And as you can see, a third party now is also saying that this failure was caused by XYZ. So it really does help the shops out. A third party perspective sometimes just settles that argument, if you want to call it.
yeah, and if that's a great point, Rob. And if you open this manual and you look at all the contributors and how many people work together to make this happen, and we all came to conclusions that are supported here. So many part manufacturers and experts in the field and so forth have worked together to assemble this book. And so it's been a great effort, and it's for a great cause.
Yeah, and speaking of contributors and stuff, you know, we're going to actually expand our Piston podcast just a little bit more. So next month, we've got one of the industry gurus that we've relied on for years here in the tech department, Russ Hayes. And Russ is actually going to be speaking on pistons as well. And Russ gets right into the nitty gritty as far as manufacturing, you know, and that kind of stuff. And I know you've had a close relationship with Russ for a long time, Chuck. So I'm looking forward to next one too. It's going to be really, really good.
Yeah, I was talking to him the other night, and I said, you know, Russ, we started working together in August of 1995. So it's been a day or two.
Exactly. And you know what, Russ is he's very familiar with a lot of different brands of pistons. He's not just a one brand guy, you know, one size fits all. He's very familiar with a lot of pistons. So whether it be diesel or gas, but he's going to get right into, like I say, he's going to talk about just, the manufacturing of a piston, what goes into the engineering side a little bit, and the design, which is, in a lot of cases, the design of the piston plays a huge role in its success. So that'll be one that we're doing for next month. Chuck, something that we talk about a little bit, that I see sort of in the power sport industry a lot, is there's reference to what they call cold seizures, and you see that with pistons. Could you maybe just expand a little bit, like what basically is it when you hear the term cold seizure? What are they referring to there?
When you have a cold seizure, and it can be different a little bit in the power sports, especially because if you don't allow components to normalize, then you weld stuff up, right? Now we see this in automotive stuff too, and that's where four corner scuffing kind of happens. Is you'll see at the size point, the stiffest point of the piston, and actually I can use that. I have an example here. When I say the stiffest point of the piston, that's usually where the size point is. So around where at the bottom, let's see if I can get this right in the camera. At the bottom where the pin boss is, they will. Um, there's usually a ring, and see the bottom here.
Mm-hmm.
Um, that groove area that's machined into the piston.
Yep.
So there's usually a device that they're set on, they square up in the boring operation for the pin boring and all that. But that's like the stiffest area of the piston, and that's usually your size point. So you see where that identifier is. It says, okay, measure the piston here. So a lot of times on a seized piston, if you were to measure right there, that part's not even damaged, right? But it'll be damaged, out here in this area and the other corner, because there was nothing wrong with the sizing of it. It's just that thing got the thermal expansion happened so quick that it stuck it in the bore. To the average person that doesn't know anything about the machining part of it and the thermal dynamics of the piston itself, they're like, "Oh, you sized it wrong." Well, wrong for your giving it everything it's got right away before it has any heat in it. So
Yep. I
power sports is much worse about that than automotive.
Exactly.
That's a fact.
No, very true. I know we used, when we had the shop, because we did a lot of power sport machine work in that, and you know, we would get blamed all the time for either not clearancing. They'd say it was a clearancing issue, or a lot of times, sometimes it gets mistaken as, well, it got overheated or it got hot. Well, actually, in the case, it actually didn't get hot enough soon enough. That's generally what the cold seizure is. It, like you said, Chuck, the components just don't have a chance to get up to temperature, and of course, the piston starts expanding way faster than the cylinder. Next thing you know, you got a big seizure on your hands. So, um,
Right? The cooling jacket's it's doing its job.
right.
But the piston heat is coming up so much faster than all the other things around it, so there's no thermal expansion anywhere except the piston.
Right. So, yep, super important, especially, snowmobiles, for example. You got to warm it up. You can't just lay the boots to it right off the get-go and expect it to, it's going to be a pretty short ride and a pretty short Sunday. You're loading up and heading home. So it's we do see that every now and then for sure. Well, Chuck, like you
That's a
mentioned,
fact.
so that failure analysis manual, that is on our website. So again, that is we use that manual all the time. Very, very good reference. And yeah, thanks, Chuck. That was a great presentation. It's good to see stuff that we don't typically always see. So again, appreciate your efforts on that. For everybody out there, if you're not subscribed to the Engine Professional podcast, you can subscribe. It is on our YouTube channel, as well as you can listen to our podcast on any of the podcast listening services. They're available. Again, you can go to our YouTube page. You can find our podcast there. So I'd encourage everybody to have a listen. We always like your feedback, as well as we always want to hear what you want to hear us talk about. So you can email us. We have our own email address. It's eppodcast@aera.org. So by all means, please email us and let us know what you want us, particular topic that you want to hear about. and or any questions that you've got, by all means, please go ahead and send that to us. I want to thank everybody for listening and taking your time out of your day to have us share some of this information for you. Chuck, just if you want, blow that smoke back up here. We're okay with it. So you, you stay cool.
Just don't send us the fire, buddy.
All right. Well, thanks, Chuck. You have a good one. We'll talk to you next month.
Until next time.